Hey everybody. I'm a little out of practice on making videos after doing this all day, every day last year. So bear with me. I forgot my stylus, so we're gonna have to go old school and use this with the iPad. So if it adjusts its focus a little bit, sorry about that. Pause as you need to get them to stop and take notes. What I'm gonna do is work the 2 example problems on your notes from today. So on the front, it goes through and tells you step by step what you need to do. So we're going to follow those steps as we go, but we're going to work them for problem 1 and then problem 5. So I'm going to talk you through it. If you have questions, shoot me an email today and let me know. So yesterday in class, so I'm recording this on Thursday, so actually this was Tuesday's class, we talked about how to factor using the box if you knew one of the factors. So if we had like a x cubed or an x to the 4th and we knew that one of the factors was x minus 1, we could go through, we'd put it right here, we'd work backwards until we figured out what this top row was. So that's what we did in class on Tuesday. And then we got to something that... as I'm shuffling papers here, we might have ended up with something like this. And I told you guys, I was like, okay, I'm happy if we can get that far after we're doing the box, and we'll come back and talk about how to do this. And so that's what we're doing today, is to talk about how to break this second one apart. So that's what we're looking for. And here is the model that they use. So basically what we're trying to figure out is what goes in A, B, C, and D. And we are looking at these for polynomials where your leading coefficient is 1. Is not 1. The reason why I say that is because sometimes if your coefficient is 1, you can just guess. Like you can look at it, you can guess and check it. When it's something like this, where it's like 3x squared, it's a lot harder to do in your head, and writing it out is really helpful for a lot of people. So I'm going to walk you through those steps. So the first thing you want to do is you want to take whatever your x squared term is and you write it right here. And then you take whatever your constant term is and you write it down here. So far, vaguely familiar, hopefully, from what we've done in class using that same kind of model. Now what's different, and if you're following along on your steps, this is step 2. What we have to do is we have to multiply these 2 things together. All right, so I'm going to do 3x squared times 12, and that's going to give me 36x squared. So now what we need to do is we need to write down all the possible factors of 36. And one of the things they mentioned in there is make sure that you're doing it as with your variables. So it's not only just what multiplies to give us 36, it's what multiplies to give us 36x squared. So 1x and 36x will give us 36x squared. 2x and 18x will give us 36x squared. 3x and 12x, 4x and 9x, and 6x and 6x. So those are all the possible factors we have of 36x squared. So that was step 2. For step 3, what we need to do is we need to pick one of these pairs. And one of these pairs of numbers are going to go in these boxes right here. The way we choose is we look at our middle number in the polynomial, just like we were doing when we were looking on the diagonals. That's basically what we're doing. We're figuring out what goes here on our diagonal. So it has to add up to be 13x. So we look at all of these, and 4x and 9x add up to be 13x. So those are the 2 factors we're going to use. That's what's going to go in on our diagonal. It does not matter which box you put them in. So you can do the 4x here and the 9x down here, or you can flip-flop it. It doesn't matter. You will get the same answer at the end. You're good either way. All right, so now that we have that, we really just pick a spot and start. So right here, if I'm looking at these, what do they have in common? And actually, I lied. They had you do it this way. It doesn't really matter, but let's match the stuff so I don't confuse you. So looking at this, what do these have in common? Well, they both have an x. That part's easy. And then they're also both divisible by 3. So we can put a 3x right here. All right, so if I know that's 3x, now that I know that piece, everything else is unlocked for us to be able to find the variables. Or I'm sorry, to find the variables for a factor. So if this is 3x, this has to be 3x squared. That means this has to be an x for that to work. X times 3x gives me 3x squared. So yeah, that works. So if I know that, now I can come over here and say, okay, x times what gives me 4x? Well, that has to be 4. And then last step over here, okay, if that's 3x, I need it to be 9x. That means this has to be a 3. And just like on Tuesday, your constant term is still your check. Double check that if you multiply these two things together, you do actually get your constant. So if we do 3 times 4, yes, we get 12. So that lets us know we did it right. If those don't work, that's your check. Like you almost don't even have to go back and FOIL it out or multiply them together. As long as these two work, you should be good to go. So what this tells us is that our answer is 3x plus 4 times x plus 3. So in factored form, that's what we end up with. Okay, so that's the steps, basically. So you put your x squared term, whatever that is, in the top left. You put your constant term in the bottom right. You multiply them together. And you figure out what numbers multiply to give you that. And then you look at each of those pairs of factors and figure out what will add up to give you that middle term. So we were looking for 13x, and so that's why it's 4x and 9x. Once you pop them in, then it's just a matter of taking a GCF and going from there. All right, so let's try one more. So if you notice in this one, all the numbers were positive, so that makes it a little easier. When you have some negatives, doesn't change the process, it just changes a couple things that you need to think about. All right, so let's follow those same steps that we did on the last one. All right, so first we have a 3x squared, so that's going to go there. Then our constant term goes in the bottom right, so it's there. Now I got to multiply those together. So 3x squared times 6 is going to give me 18x squared. All right, so now I need all the factors of 18x squared. So that's 1x and 18x, 2x, 9x, 3x, and 6x. All right, here's where things get a little interesting. So we need to find which one adds up to be negative 19. All right, well, hold up. I don't have any negatives over here. So let's look at this for a second. They had to multiply to be 18, positive 18, x squared. So the only way you are getting a positive number right there is if you had a positive number times a positive number, or you had a negative number times a negative number. So if we need it to add up to be a negative, that means these all have to be negative. And so that's the piece of problem solving that you're going to have to do for yourself. You're going to have to look at this number, compare it to this number, and figure out where your negatives go. So if this was a negative 18, the only way I could get a negative number is if I had one positive and one negative. And so then your job is figuring out, okay, which one of these in each pair needs to be positive and which one in each of those pairs needs to be negative. So that's the one part that gets a little tricky. And there are some example problems on here that take you through that. All right, so I'm looking for negative 19x. That one works. Negative 1x plus negative 18x is going to give me negative 19x. All right, so those are the two factors I'm going to use. Throw them in the box anywhere you want. Doesn't matter. For this, I like to write the negative 1 in front of there. Normally I don't, but when I'm factoring, it helps just keep me organized, so I do like it. All right, so again, following their method, but it doesn't really matter. You could pick really any row or any column to start with. But if we're going to follow theirs, we're going to go with A. So we want to look and find what's the GCF. What do they have in common? So, well, they both have an X. And again, they both have a 3. They're both divisible by 3. So once I have that, I can go through and unlock everything else. So if this is a 3x, that means this is an x. If this is an x, I need it to be negative 1x. So that's a negative 1. Down here, this is 3x. I need it to be negative 18x. So that means that's going to have to be negative 6. Oops, no x, just negative 6. And then we stop and check. So negative 6 times negative 1, yes, that's going to give me a positive 6. And when we're dealing with negatives, that's where that check really comes in handy, because a lot of times if you flip-flop it, you're going to end up with an opposite sign here. So taking a moment to double check that everything works out is absolutely worth it. All right, so that is basically as complicated as I could make it. You end up getting 3x minus 1 times x minus 6 in factored form. And there you go. So that's it. At this point, you've seen all the different types of factoring. So we've talked about the special case that is difference of two squares. We've talked about GCF. We've talked about trinomials. Hopefully this is ringing bells for those of you that have seen factoring before. For those of you that haven't, hopefully this starts to help to unlock that process for you. Please try the practice problems. I think it's worth, this is one of those skills where it is worth just straightforward practicing, going through and making sure you've got it. I will post the answer key with the answers to all, what is that, all 8 problems? Yeah. So you can check yourself and see how you did. Obviously, we've done number 1 and number 5. So there's 6 more problems for you to practice with. I hope you guys have a great day. I hope you get some rest. Take a break during class, okay? I'll talk to you all later. See you on Friday. Bye.